Hey everyone, ready for another deep dive. Today we're going to be exploring the quantum charge matrix,
Ah,
which is
yes.
really shaking things up when it comes to drug design.
Absolutely.
Basically, it's like this new tool that helps us understand
Mm,
how molecules are going to interact with each other.
right. It's really fascinating because the quantum charge matrix, or QCM as it's often called, really allows scientists to
Right.
predict how a drug is going to behave before they even start doing any experiments in the lab.
Yeah, that's kind of what really caught my eye too.
Right.
And one of the examples that I saw when I was reading about this was
Uh-huh.
this drug called quantum longevitol.
Oh, wow.
And they're
Interesting.
saying that this drug can actually target those aging cells,
Mm-hmm.
those ones that we want to get rid of.
Right.
And it can even boost the power of our mitochondria, which
Yes.
is like the powerhouse of the cell.
Exactly. It is.
It's pretty exciting stuff.
Yeah, the potential is definitely there. But before we get too carried away talking about, all the amazing things that this drug might be able to do, we really need to understand the science behind it.
Okay, so let's break it down a little bit then.
Yeah.
So every element on the periodic table gets assigned its own quantum charge,
Right.
right? So it's like
Yeah.
each atom has its own little ID card.
Exactly.
Okay. And so this quantum charge, or this Q value as they call it,
Mm-hmm.
it's not just a random number.
No, it's not just a random number. It actually is based on a calculation
Okay.
that considers how strongly an atom attracts electrons,
Okay.
how hard it is to remove an electron from that atom,
Mm-hmm.
and how readily it accepts a new electron.
Okay, so it's like this profile for how each atom likes to behave.
Yes, you could think of it like that. It's a
Yeah.
personality profile
Go.
for the atom.
Right.
And it considers all these different factors like electronegativity,
Right.
ionization, energy, electron affinity.
Okay.
All of those are combined into this one value.
Okay.
So if we look at hydrogen, for example, hydrogen has a quantum charge of plus 0.5.
Okay.
So that positive value tells us that hydrogen is pretty happy to share its electron.
Gotcha. So then, on the other hand, you have something like oxygen,
Yes.
which is a little bit more
a little bit more greedy.
greedy.
Yes.
Okay.
Oxygen has a negative quantum charge of minus 0.6.
Okay.
So that means it really likes to attract electrons. It's electron negative.
It wants to hold on to them.
It does.
Okay.
And that difference in their quantum charges, that's actually what helps us understand why they form such a strong bond in a molecule like water.
Okay.
So the greater the difference in those Q values,
Uh-huh.
the stronger the attraction is going to be between those two atoms.
So it's not just telling us how strongly they're going to bond, but what type of bond as well.
Exactly. Yeah, we can look at whether it's a single bond, a double bond, or a triple bond,
Right.
depending on how many pairs of electrons are being shared between those atoms.
And of course, we can't forget about those ionic bonds, where it's like one atom is just giving its electron away completely.
Absolutely, that's right.
Okay, so we've got these quantum charges.
Yeah.
We know they're impacting how atoms are bonding with each other.
Yeah.
But how do we take that information and actually use it to design something as complicated as a drug?
Right. Well, you can kind of imagine building a molecule like a puzzle,
Okay,
where each atom is a piece of that puzzle.
gotcha.
And the quantum charge matrix, that's kind of like our instruction booklet,
Mm-hmm.
that tells us how all those pieces fit together.
Okay.
So by tweaking the quantum charge of different atoms,
Okay.
we can actually sculpt a molecule to interact with a specific target in the body.
So we're kind of doing this molecular matchmaking.
Yes.
We're trying to find that perfect fit.
That's a great way to put it, yeah.
Okay.
So we're looking for the perfect fit for a drug to interact with a specific protein or a specific enzyme in the body.
So that's where the real magic happens then.
Yes, that's where it gets really exciting because by understanding these quantum interactions, we can design drugs that fit perfectly into their target,
Mm-hmm.
like a key in a lock.
Okay.
And that means that they're going to be more effective and hopefully they'll have fewer side effects as well.
That's amazing.
Yeah.
So can you give us an example of how this actually works in the real world?
Sure. So let's take aspirin, for example.
Okay.
Aspirin is a common pain reliever that many people take. And it works by blocking an enzyme called COX.
Okay.
COX is involved in inflammation.
Okay, so how does aspirin manage to block COX?
Well, aspirin has a specific group of atoms called a carboxyl group.
Mm-hmm.
And that carboxyl group has a negative quantum charge because of the oxygen atom that's in it.
Okay.
So that negative charge is attracted to a positive area on the COX enzyme.
Okay.
And they form a bond, and that actually prevents the COX enzyme from doing its job.
So it's like aspirin's giving COX a hug it can't get out of.
Exactly. Yeah. That's a good way to think about it.
Okay, and this works with other drugs too.
Yes, definitely.
Okay, can we look at another example?
Yeah, sure. So let's look at metformin.
Okay.
Metformin is a drug that's often used to treat type 2 diabetes,
Mm,
and it works by activating an enzyme called AMPK.
okay.
AMPK is involved in regulating our metabolism,
Okay.
and it's been linked to longevity as well.
Interesting. Okay.
So metformin has these groups of atoms called guanidine groups,
Mm-hmm.
and those guanidine groups, they're really good at donating electrons.
Okay.
So those electrons, they interact with specific sites on the AMPK enzyme,
Okay.
and that actually makes the AMPK enzyme more active.
So it's like metformin is giving AMPK a little boost of energy.
Exactly.
Okay, so these are just two examples of how this is working.
Yeah.
But there are tons of other drugs out there that are being designed using this approach.
Right. The potential here is really huge.
This is amazing.
Yeah.
I mean, it seems like the quantum charge matrix
Mm-hmm.
isn't just helping us design drugs that are more effective, but it can also help us understand and maybe even minimize the side effects that some of these drugs can have.
That's right. And that's a really important point because, as you know, many drugs have side effects.
Right.
So let's look at an example.
Okay.
There's a chemotherapy drug called doxorubicin.
Mm-hmm.
It's a very powerful drug that's used to treat cancer,
Okay.
but unfortunately, it can also damage the heart.
Right. I heard about that.
Yeah, it's a serious side effect, and we want to be able to avoid that if possible. So it turns out that doxorubicin has a positive charge.
Yeah.
And that positive charge can sometimes interact with negatively charged molecules in the heart cells.
Gotcha.
And that's what causes the damage.
Oh, so it's not actually targeting the heart cells?
No, it's not specifically targeting them,
Okay.
but because of its positive charge,
Right.
it can sometimes bind to them unintentionally.
Oh, I see.
And that's where the QCM can be really helpful, because if we understand these interactions at the quantum level,
Yeah.
then we can actually modify the drug
Uh-huh.
to try to prevent that unwanted binding.
So it's like giving it a shield almost.
Yes, you could think of it like that.
Okay.
We're trying to protect the heart cells
Okay.
from that unintentional damage.
So before we go too much further,
Yeah.
you mentioned earlier this drug called quantum longevitol,
Right.
this longevity drug.
Yes.
I'm very curious to hear a little bit more about that. How was this drug designed and what makes it so special?
Yeah, so quantum longevitol, it was designed to be like a multi-pronged attack on aging.
Okay.
So it targets several different processes that contribute to aging.
Okay, so what's in this cocktail then? What makes it tick?
Well, one of the key ingredients is a modified version of a molecule called NAM.
Okay.
NAMN is a precursor to a really important molecule called NAD+.
Mm-hmm.
And NAD+ is essential for our cells to produce energy
Okay.
and to repair damage.
So it's kind of giving the cells a boost.
Exactly. It's like giving them a fresh supply of fuel.
What else is in there?
So another key ingredient is a really powerful AMPK activator.
Mm-hmm.
Remember we were talking about metformin earlier?
Right.
Metformin activates AMPK.
Right.
Well, the AMPK activator in quantum longevitol is even stronger.
Oh, wow.
So it's really going to boost that metabolism and help the cells clean up all the junk that builds up inside them.
So it's like giving our cells a personal trainer.
Yes, that's a great analogy.
Yeah. Anything else in there?
Yes, so they also included a really potent anti-inflammatory component in this drug.
Right.
As we age,
Mm-hmm.
inflammation becomes a much bigger problem.
Right.
It contributes to all sorts of age-related diseases.
Okay.
So we really want to keep that inflammation under control.
So it's kind of putting out the fires as we age.
Exactly. That's a great way to think about it.
Okay.
So they used the QCM to design a molecule
Mm-hmm.
that specifically targets those inflammatory pathways,
Okay.
but without causing other side effects.
So it seems like they've really thought of everything with this drug.
They've really tried to cover all the bases.
This is incredible. I'm very eager to hear more about the potential benefits of this drug and where the research is headed.
Yeah.
But for now, we're going to take a quick pause.
Okay.
Don't worry, we'll be back soon to dive deeper into the specifics of quantum longevitol and what this could mean for the future of aging.
Sounds good.
Stay tuned.
All right.
All right, so we're back and ready to dig a little deeper into this quantum longevitol.
Right.
You mentioned that it targets multiple aging pathways.
Yes.
What exactly does that mean?
So it seems that it really tries to tackle those key hallmarks of aging, things like cellular senescence, mitochondrial dysfunction, and of course, chronic inflammation.
Right, because all of those things are kind of interconnected.
Exactly. They all contribute to that overall decline
Yeah.
that we see as we get older.
Okay, so let's unpack that a little bit.
Okay.
Let's start with cellular senescence.
All right.
You said that quantum longevitol targets these senescent cells.
Yes.
Just remind me, what are those again?
So you can think of senescent cells as kind of like the body's retired workforce.
Okay.
They've stopped dividing, but they haven't quite gotten the memo to completely clock out.
Oh, so they're just hanging around?
They are, and unfortunately they can cause some trouble.
So they're not just harmless bystanders.
Not exactly, no. They actually release these inflammatory molecules that can damage the surrounding tissues,
Oh.
and they can contribute to a lot of those age-related problems that we see.
So they're not just sitting there quietly.
No, they're causing trouble.
Okay, so how does quantum longevitol deal with these cells?
So it seems to contain a modified version of navitoclax,
Okay.
which is a drug that is known to induce what we call apoptosis in those senescent cells.
Okay, and apoptosis, just to remind me, is
Programmed cell death.
it's like the self-destruct button.
Exactly.
Oh, wait.
And what's really interesting is that they seem to have used the quantum charge matrix
Uh-huh.
to refine the structure of navitoclax
Okay.
and make it more targeted towards those senescent cells.
Okay, so less damage to healthy cells.
Hopefully, yes.
Okay, so we've taken care of those senescent cells.
Yes.
Now, what about mitochondrial dysfunction?
Okay.
How does quantum longevitol address that?
So remember we were talking about NAD plus
Yes.
and how it's so important for those mitochondria to
Yeah.
function properly.
Right.
Well, quantum longevitol, it includes this modified version of NMN, which is a more stable and effective precursor to NAD plus.
Okay.
So it's really designed to boost those NAD plus levels.
So it's like giving the mitochondria a fresh batch of batteries.
Exactly.
Okay.
And in addition to that, it also includes that powerful AMPK activator that we were talking about before.
Right. The longevity enzyme.
Yes, exactly.
So remind me again how activating AMPK actually benefits us.
So you can think of AMPK as the cell's energy manager.
Okay.
Activating it is kind of like mimicking the effects of exercise
Okay.
and calorie restriction.
Which we know are good for longevity.
Exactly.
Okay.
So it really boosts that mitochondrial efficiency.
So it's like giving our cells their own personal trainer.
Exactly. It's like a workout for the cells.
I like it. All right. And then, of course, we have to talk about the anti-inflammatory component as well.
Yes, because as we age, chronic inflammation becomes a major driver of so many diseases.
Right.
It's like this constant low-grade fire
Right.
that's burning throughout the body.
And kind of speeding up that aging process.
Exactly.
Okay. So how does quantum longevitol address that?
So while the exact details of this anti-inflammatory component, they're still kind of under wraps.
Okay.
It seems that they've used the quantum charge matrix
Oh.
to design a molecule that very specifically targets those inflammatory pathways
Okay.
without causing other side effects.
So it's like a very targeted weapon
Exactly.
against inflammation.
That's a great way to put it.
Okay. So it sounds like this quantum longevitol, it really has a lot going for it.
It does.
Could it really help us live longer, healthier lives?
Well, the research is still in its early stages, but the data that they have so far from animal studies,
Uh-huh.
it is really promising.
Okay, so what kind of results are we talking about?
So they've seen increases in both lifespan and health span,
What?
reduction in the risk of age-related diseases like cancer and heart disease,
Wow.
improvements in cognitive function,
Okay.
even enhanced physical performance.
That's pretty impressive.
It is exciting stuff.
But of course, with any new drug, we have to talk about side effects.
Of course.
Are there any potential downsides to taking quantum longevitol?
That's a great question. And so far, the preclinical trials,
Uh-huh.
they haven't shown any major side effects.
Okay.
But of course, more research is needed,
Well,
especially in humans,
of course.
to confirm that it's safe and effective.
Okay, so what's next for quantum longevitol?
So the next big step is to move into human clinical trials.
Okay.
So they need to test it in people and see if those promising results that they saw in animals actually translate to real-world benefits.
That's exciting. When do you think those trials might start?
It's hard to say for sure.
Okay.
You know, they need to get funding. They need to get regulatory approval.
Right.
Those things take time.
Yep. Yeah.
But hopefully it won't be too long before we start seeing some results from those human trials.
Fingers crossed. Well, this deep dive has been fascinating.
It has.
I feel like I've learned so much about drug design and the potential of this quantum charge matrix.
It's a really exciting field.
It is. Is there anything else about the quantum charge matrix that you think our listeners should know?
Yes, actually, there's one more thing that we haven't talked about yet, and that is its potential for predicting the behavior of new elements that haven't even been discovered yet.
Wait, hold on. Predicting new elements. That sounds like something out of science fiction.
I know it sounds crazy, but it's actually based on those same fundamental principles of chemistry and quantum mechanics
Okay.
that we've been talking about this whole time.
Okay, so just to kind of back up for a second.
Yeah.
The periodic table, it's not just some random assortment of elements.
Right.
There's a reason why they're arranged the way they are.
Exactly.
And we see these recurring patterns in their properties.
Yes.
Right, like you were saying before, elements that are in the same column, they tend to behave similarly.
Exactly. And those similarities, they're not just a coincidence.
Yeah.
They actually stem from their electron configurations, which ultimately dictate their quantum charges and how they're going to interact with other elements.
Okay, so by understanding these quantum properties
Right.
and these trends in the periodic table, scientists can essentially extrapolate and make some guesses about these undiscovered elements.
Exactly. They can predict things like an element's electronegativity,
Right.
its ionization energy, its electron affinity,
Oh, okay.
and that allows them to kind of estimate its potential bonding behavior and even its physical properties.
That's incredible. Are there any real-world examples of this?
Absolutely. There are many elements, especially those heavier than uranium,
Okay.
that were actually predicted long before they were ever synthesized in the lab.
Wow.
Their existence and their properties were hypothesized based on those gaps and patterns in the periodic table.
So scientists knew that they should be there, even though they hadn't found them yet.
Exactly. It's like having a map to uncharted territory.
Yeah.
And the quantum charge matrix, it just adds to that predictive power.
Okay.
It gives us even more insight into how these new elements might behave.
So we're not just talking about predicting their existence.
You're right.
We're talking about how they might bond with other elements.
Exactly.
And the kinds of properties they might have.
And potentially create new compounds that have never existed before.
This is blowing my mind.
Yeah.
I mean, we're talking about materials that have never existed before.
It's pretty amazing.
What could that mean for the future?
The possibilities are really endless.
Yeah.
We could see new materials that are incredibly strong and durable,
Right.
new catalysts for energy production,
Mm-hmm.
maybe even new forms of computing based on these exotic quantum phenomena.
It's like a whole new world of possibilities opening up.
It's really exciting.
This quantum charge matrix is not just about understanding what we know. It's about unlocking the unknown.
Exactly.
This has been an incredible deep dive.
Yes.
I feel like I've learned so much
I'm glad to hear that.
about this fascinating field of quantum chemistry.
Me too.
And I'm sure our listeners are eager to learn more as well.
I hope so.
So for those of you who want to dive deeper, where would you recommend they go?
Well, there are some great books and online resources out there
Okay.
that really delve into quantum chemistry and its applications.
Okay.
So 2 books that I would recommend are Quantum Chemistry by Ira Levine
Okay.
and Physical Chemistry by Peter Atkins and Julio de Paula.
Great suggestions.
Those are really good starting points.
And of course, there's always the world of scientific journals and research articles.
Yes, definitely.
For those who want to really get into the nitty-gritty.
If you want to go deep, those are the places to go.
Exactly. But the most important thing is to stay curious.
Absolutely.
The more you learn.
The more you realize how much more there is to learn.
Very well said. Well, on that note, we've reached the end of our deep dive into the quantum charge matrix.
It's been a pleasure.
Thank you so much for joining us on this journey.
My pleasure.
And to our listeners, thank you for tuning in.
Yes, thank you.
And remember, stay curious.
Stay curious.
Okay, so before we took that break, we were talking about how this quantum charge matrix can actually predict the behavior of elements that haven't even been discovered yet.
Right. It's like getting a sneak peek at the future of the periodic table.
It really is.
Yeah.
So where does that come from? How is that possible?
Well, it all goes back to the fact that the periodic table, it's not just a random assortment of elements, right?
Right.
It's very organized. It's based on these recurring patterns that we see in their properties.
Right, like we were saying, elements in the same column, they tend to behave similarly.
Exactly. And those similarities are not just a coincidence.
Right.
They're actually driven by the principles of quantum mechanics.
Okay, so it all comes back to quantum mechanics.
It does. Those
yeah.
similarities stem from the way their electrons are arranged, their electron configurations, and those configurations ultimately determine their quantum charges
Okay.
and how they interact with other elements.
So by understanding these quantum properties and how they relate to the arrangement of the periodic table, scientists can sort of make some educated guesses about what these undiscovered elements might be like.
Right. They can predict things like electronegativity,
Okay.
ionization energy, electron affinity,
Gotcha.
All of those properties allow us to kind of estimate how it might bond with other elements, what kind of physical properties it might have.
That's incredible. Are there any examples of where this has actually happened?
Oh, absolutely. Many elements, especially those that are heavier than uranium,
Okay.
were actually predicted long before we could even create them in the lab.
Wow.
And so their existence and their properties were all hypothesized based on filling in those gaps in the periodic table.
So they knew they should be there, they just hadn't found them yet.
Exactly. And the quantum charge matrix just enhances that predictive power even more.
Okay.
It doesn't just tell us that they should exist,
Right.
but it gives us a glimpse into how they might bond with other elements, how they might behave.
So we could potentially even create materials that have never existed before.
Exactly. It's like opening a door to a whole new world of possibilities.
So what could that mean for the future? I mean, what kind of new materials are we talking about?
Well, the possibilities are vast. We could have materials with unprecedented strength,
Okay.
durability, new catalysts that revolutionize energy production, maybe even new forms of computing
Wow.
based on some of these exotic quantum phenomena.
So the quantum charge matrix, it's really not just about understanding the known, it's about unlocking the unknown.
Exactly. And that's what makes it so exciting.
This has been a really incredible deep dive.
It has been.
I feel like I've learned so much about quantum chemistry and all of its possibilities.
It's a fascinating field.
It really is. And for our listeners who are now super intrigued and want to learn more, what would you recommend? Where should they go?
Well, there are many great resources out there.
Okay.
Books, online resources that can really help you delve deeper into this field.
Okay.
2 books I always recommend are Quantum Chemistry by Ira Levine
Okay.
and Physical Chemistry by Peter Atkins and Julio de Paula.
Great suggestions. And then, of course, there's always those scientific journals and research articles.
Yes, definitely for those who really want to dive into the nitty-gritty details.
Exactly. But the most important thing is to stay curious.
Absolutely. Keep learning, keep exploring.
Couldn't agree more. Well, on that note, we've reached the end of our deep dive into the quantum charge matrix.
It's been a pleasure.
Thank you so much for joining us.
It's been my pleasure.
And to our listeners, thank you for tuning in.
Thank you.
We'll see you next time.
Until then, stay curious.